Hello, and welcome to SciTechNature, May 5th, 2020. We've got some interesting things today, and I think we should get stuck right into it. Last week, we saw the rotation of Ganymede, the third moon out from Jupiter, and today we've got Pat Singer sent this link, which has the moon doing the same rotation, which recently came out as well. So thank you, Pat, and let's take a look at it. So you might be asking yourself, what do all those beautiful colors mean? Well, I wanted to know, and it took me 25 minutes of looking around before I finally found something that remotely would tell you what the colors were determined, or what kind of rock it was. I've put the link down below. You really need a higher resolution to get it. You'd think that every publication I looked at, they didn't give any kind of way of determining the color and what it meant. They must think that the audience are really stupid and don't care. At around noon, a group of us SciTechNature people got together on Zoom and had a really good chat. It was a lot of fun, and I really enjoyed it. One of the members suggested, and I wish I could remember who it was who made the suggestion, sent this really excellent map of San Miguel de Allende air quality. And there's been a lot of debate and discussion about the air quality because some of the monitors that are supposed to measure the San Miguel air quality are not in San Miguel at all, apparently. So this is a much more positive map, and I'll put it down in the links below. Enjoy. Looking at that previous map, I couldn't but help notice that the graphic was taken from a weather map that I was quite familiar with. I have shown it to members a few times, but just in case you haven't seen it, I'm placing it down below as well. It's just a remarkable map, and it shows you so many different aspects of the weather. If you click on the thing that says Earth right here, you can see it has the air quality. So as soon as you hit that, it changes. It gives you the air, the oceans. So it gives you how the oceans are behaving at a given day. Chem must be the chemistry that is floating around in the atmosphere, and particulates. You have that too. I see all that sand blowing in from the Sahara there, and space. Well, space gives you the aurora. Look at that. It gives you the aurora borealis. I just think that's aurora australis. Just think that's really cool. So down below, you'll find the link for that. Last year, a video emerged from the United States Air Force. I don't know through which channels, but it went across the entire news network And when they asked the United States Air Force if it was real or not, they would not comment, but they were sort of given to understand that it was real. Well, last week, the United States Air Force officially published it and said, yes, this is real. And that's what makes this rather extraordinary. And I frankly don't want to make of it. So I'm just going to give it here for your edification 2.5 minutes of something really strange.
Gosh. We're all going against the wind. The wind's 120 knots from the west. Look at that thing, dude. That's not our LNS though, is it? It's not. That is the LNS, dude. Well, if there's a... Look at that thing. It's rotating. Cycle 6-1 Tango Logic, over. Oh, got it! Woohoo! Roger, they're troubleshooting as soon as I get... Did you box moving target? No, I took an auto track. Oh, okay. Oh my gosh, dude. Wow, look at that, man. Look at that.
I hope you enjoyed the overlay music in the last part of it. There was no audio there, so I thought I would add a little drama to it. That wasn't the sound of the spacecraft. All right, let's move on. This next article, dug out of India Times from a Reddit user called Vast Reaches. And basically, this guy captured the sun's atmosphere from his backyard. And good description here, despite it being a rather short article. Now, here's the beautiful picture that we can see here of this sort of very, very hot plasma rain coming down onto the sun's chromosphere. When it comes to the coronavirus, Rob Lerner is very good at separating the wheat from the chaff. So I'm very pleased to pass on this Atlantic publication, why the coronavirus is so confusing. It's in depth and it breaks it down really well. It's down below. It's definitely worth reading. Groupthink probably does more to inhibit the advance of science than anything else, including the lack of funding. We see groupthink throughout history. One thing that comes to mind is the Ptolemaic idea that the Earth was in the center of the solar system, and complex mathematics was built around this idea that made it sort of work, but it was wrong. And it remained wrong, basically because everybody subscribed to it, even though the concept of a sun in the center of the solar system had been described in 300 BC by Aristarchus. So we tend to hit these dead-end alleys and stick to them with a religious zeal that is unwarranted. And one of the examples I'm going to show is that the 90 years in an attempt to create nuclear fusion has been essentially a failure. And I'll describe why I think this is after the initial presentation.
Fission is what happens when a neutron slams into a larger atom, which splits it into two smaller atoms. Additional neutrons are also released in this process and can start a chain reaction by slamming into more atoms to continue the process. When an atom is split, a massive amount of energy is released, which generates heat. In the nuclear reactors that we have today around the world, the heat is captured to turn water into steam, which then turns a turbine and produces electricity. Fusion is the opposite of fission, and it's what's happening in our sun and all stars in the universe. Fusion is when two atoms slam together to form a heavier atom. Fusion reactors can use deuterium and tritium. When heated to 150 million degrees and slammed into each other, they produce helium and a neutron. Fission reactions don't occur normally in nature, but as I mentioned before, fusion does, and it occurs in stars. One big benefit of fusion over fission is that it doesn't produce highly radioactive fission products. It's also safer because of how the nuclear chain reaction behaves. In fission, the chain reaction of splitting atoms can get out of control, which will either cause an explosion or a reactor meltdown and release massive amounts of radioactive particles for years and decades into the future. While nuclear reactors are very safe in practice, there have been several notable examples of what can happen if something goes wrong. All you have to do is look at 3 Mile Island in 1979, Chernobyl in 1986, or Fukushima in 2011. Fusion reactions, however, are very different. It takes a massive amount of heat to create plasma in the center of a fusion reactor. Plasma is superheated matter that gets so hot, it rips electrons away from the atoms, forming an ionized gas. The freed nuclei, which are positively charged and usually repel from each other, start bouncing around at great speeds and confuse together, which releases energy in the process. If a fusion reaction becomes unstable or unbalanced, it naturally slows down, dropping the temperature until it stops. The worst case scenario is damage to the fusion reactor and the immediate surroundings, but very little else. But the safety benefits aren't the only reasons we're working to build fusion reactors. Instead of using something like uranium and plutonium as a fuel source, fusion reactors can use deuterium and tritium. Both deuterium and tritium can be extracted from seawater and lithium, and so there's enough fusion fuel on Earth to power the planet for millions of years. So what's the catch? Well, it's a big one. We haven't been able to produce a fusion reaction in an energy efficient and sustained way yet. It takes more energy to generate the heat and pressure needed to create the fusion reaction than the energy we get out of it. This is referred to as the fusion energy gain factor. It's the ratio of energy to maintain the reaction versus what it's actually producing, which is often expressed by the symbol Q. So a Q of 1 would be break even. A Q of 2 would double the energy that you put in, and a Q that's less than 1 would mean a loss of energy. In 2017, the record for Q was set by the JET tokamak reactor in the UK, which was a Q of 0.67. But there's a lot of nuance to that because these reactions and experiments are running on cheaper hybrid forms of fuel, which aren't as efficient as deuterium and tritium. So researchers also have calculations that they use to estimate real-world performance with things like extrapolated break-even, engineering break-even, and commercial break-even. Again, that's all out of scope for this video, but I'll include links in the description if you're interested. But that's not the end of the catch. We've been researching and experimenting with fusion since the 1930s. That's right, almost 90 years. But the first fusion devices didn't show up until the 1950s. When people joke that fusion energy is always 30 years away, this is why. The predictions for when fusion energy gain factor would be at a workable level has been wrong again and again. A lot of times these predictions are coming from researchers trying to get funding, so there's some overselling going on in order to generate interest.
The product of groupthink is deeply ingrained in us, and it permeates society. For instance, consider the beginning of this really quite well done documentary, but the very premise is conjecture. No one has ever seen what goes on beneath the sun.
The sun shines because of nuclear fusion. In a nutshell, fusion is a thermonuclear process.
Did you see that? Automatically, you were led to believe that the interior of the sun is what we think it is, but it's all conjecture. No one has ever been or seen the interior of the sun. Everything that we pick from the sun, we see from the sun's photosphere and the exterior. That is a perfect example of what has been embedded in our society as groupthink. It's one of the reasons you should be extremely skeptical whenever a large group of scientists get together and build upon a concept that is not necessarily true.
A group in which groupthink has taken a hold exhibits 8 well-defined symptoms. Let's take a look. First, an illusion of invulnerability, shared by most or all of the members, that creates excessive optimism and encourages extreme risk-taking. Second, collective efforts to rationalize and discount warnings that might lead members to reconsider assumptions before recommitting themselves to the best policy decisions. Third, an unquestioned belief in the group's inherent morality, inclining members to ignore the ethical and moral consequences of their decisions. Fourth, stereotyped views of enemy leaders as too evil to warrant genuine attempts to negotiate or as too weak or stupid to counter whether risky attempts are made to defeat their purposes. 5. Direct pressure on a member who expresses strong arguments against the group's stereotypes, illusions, or commitments, making clear that such dissent is contrary to what is expected of loyal members. 6. Self-censorship of deviations from the apparent group consensus, reflecting each member's inclination to minimize the importance of his or her doubts and counterarguments. 7th, a shared illusion of unanimity, resulting partially from self-censorship of deviations, augmented by the false assumption that silence means consent. And finally, 8th, the emergence of self-appointed mind guards, members who protect the group from adverse information that might shatter the shared complacency about the effectiveness and morality of their decisions. When groupthink dominates group deliberations, the likelihood increases that decision-making defects will occur. The group is less likely to survey a full range of alternatives and may focus only on a few, often just 1 or 2. The group may not re-examine previously rejected alternatives for non-obvious gains or some means of reducing apparent costs. Even when they receive new information, the group may reject expert opinions that run counter to its own views and may choose to consider only information that supports its preferred solution.
So all fusion nuclear research is based on the concept that the sun has a huge, intense gravitational field inside that is crushing the life out of the atoms and creating energy. But let me give you one example of why this can be objected to.
It's hard to appreciate the scale of disparity between the parts that make up the hydrogen fusion core sun. At its core, the temperature is supposed to be 15 million degrees Celsius. The photosphere surface has a temperature of a mere 5,500 degrees. The corona, often described as the sun's atmosphere, varies between 1 and 10 million degrees Celsius. This is what the scientists refer to as the coronal heating problem. Magnitudes such as these can be hard to appreciate, so here is a model that can help one grasp the problem. Let us pretend we can drop the temperature of the photosphere to 0 degrees Celsius. So this shell is the temperature of the snowball. Then let us drop the temperatures of the inner core and outer atmospheric corona in proportion. So sandwiched between our snowball shell, the core would be 2,700 degrees Celsius, hot enough to melt steel. And the atmospheric corona would have a temperature that varies between 180 degrees to 1,800 degrees Celsius, a temperature so hot that if you were standing in the vicinity, you would either parboil or vaporize. Your choice. Exceedingly high temperatures, with a snowball shell sandwiched in between. According to the laws of thermodynamics, that's one hell of a problem. You can't pass heat from a hot core through a cool photosphere and then have it heat up again once it reaches the corona. Can't be done. It might have been easy for the hydrogen fusion core proponents to scale the energy output density to conveniently fit the temperature of the photospheric shell, but when the temperature of the corona was discovered to the magnitudes higher, suddenly no adjustment of the never-seen interior of the sun made any sense at all. So, based on this observation, the contemporary core theory is a bust.
So, in the light of an objection like this, and many others which I won't go into at this particular time, you would think that there would be a plethora of solar theory alternatives. So, let's turn to the Wikipedia, which is the basic foundation upon which our knowledge rests. And you'll see that there is absolutely nothing that suggests any alternative theory. Interesting, isn't it? Actually, there are a lot of alternative theories, and if you go into the construction of Wikipedia, you'll see the raging debates that have been going on with other scientists pointing out these problems and making other suggestions. But because of groupthink, the guardians that feel that they are doing a service to science are carefully keeping such things in abeyance. And that is wrong.
Three of the more notable tokamaks are the Joint European Torus, or JET, the Tokamak Fusion Test Reactor, or TFTR, in the US, and the JT60 reactor in Japan. It was also in the 1980s when an international project was launched to build one of the largest tokamak reactors in the world, ITER. This 35-year collaboration between China, the EU, India, Japan, Korea, Russia, and the US is building out a facility in southern France that should be capable of achieving a Q greater than 10. If it works out like they're hoping, it should be able to generate about 500 megawatts of fusion power from 50 megawatts of input heating power. ITER itself is not meant to be a working reactor, but a test facility to prove out the technologies and the design for the fusion power plants of the future. As exciting as that may sound, it's suffered from major cost overruns and delays. But as of right now, it's scheduled for its first plasma in December of 2025, and then ramping up to full operation by 2035.
So 50 years of building thermonuclear reactors, fusion reactors, are based on a concept that might essentially be utterly bankrupt. So we've spent countless trillions of dollars over these decades building something that we don't understand because we haven't taken the time to do the research. Plasma, which is the basic fundamental building block of a fusion reactor, is poorly understood. And because of that, the ingredient that's missing and probably can't be brought forward in this strict scientific method is magical thinking. After 50 years, you should be saying, well, what if we try this? For instance, gravity is an essential proponent of what the sun does. It's got a lot of gravity, 28 times that of what our planet does. So has anybody tried to use the centrifugal force with these tokamak reactors? Never. It's never been tried because of groupthink. Let me give you an example of something really productive that's almost like garage-based and must have cost no more than a few $100s to do, with a microwave, a drill, and something that can turn into a plasma in the microwave. These Israeli scientists took this plasma that they created. You can do it with a grape, even creating a plasma inside a microwave, and they used a drill, a high-speed drill, the centrifugal force, to spin it. Now, it's interesting that when you take a plasma, the superhot gas, there's an effect called the dynamo effect, that if you spin a plasma, it gets more excited. You'd think that they would consider this, building all these damned reactors. They've got the nice round donuts, but no one has ever spun them. Check out these Israelis doing this in the microwave.
עד שתתקשר ויגיע, כבר לא... הנה, אתה רואה, הוא מטייל ממש, אתה מצלם, כן? איתן, אתה מצלם? כן, כן, כן. תוציא אותו מלמטה, תביא עוד אחד.
The Israeli scientists did this in 2006, and it's just sort of sat there in the backwater. No one really paid any attention. You know, doing this kind of stuff when you have thousands of scientists and technicians working on something, it's virtually impossible to come up with something new and innovative. So they work with the lowest common denominator, and they stick to it, because if anybody suggested anything different, they'd be tossed out and they'd lose their wage check. That's the way it is. Let's move on. I came across this rather interesting article. Artificial intelligence is evolving all by itself. And what caught my eye immediately was, as they are programming this thing, one of the aspects of it is the survival of the fittest, which is sort of like very much a cliche of evolution. And if that's all they've put into the program, then I've got a question, which will follow this short video.
The Vogelkop bowerbird. He might lack the plumage, but he's got an extraordinary repertoire of song. And he's a wonderful mimic. Those are pigeon wing beats. That's a modest tiger parrot. And that a sulphur-crested cockatoo. Even more surprising, he's an avid collector with a very appreciative eye for colour. This male favours red and orange flowers. And he's very fond of fungus. Not everything he collects stays where it should. He puts these treasures on display within and around a construction that has taken him years to build. A giant bower woven around a central sapling, carpeted with moss. This grand design is no nest, it's the ultimate seduction parlour. But he's not alone on this hillside. He's got 6 rivals within earshot. This one prefers darker colours, decorating his bower with deer dung. And charcoal. Visual effect is of crucial importance. Clearly, he hadn't planned on all this sprouting fungus. He and his nearest rival live a stone's throw apart. Competition is intense. It's the dung ball bower that is the first to catch the female's attention. He withdraws while she inspects his workmanship. She's back again, and seems impressed. But on closer inspection, she's less convinced. Perhaps it was that sprouting fungus. Back at the flower bower, the male performs a dress rehearsal. He senses she's watching. This is the moment he's been working towards. His bower channels his song in her direction. A final check. All is to her liking. Few birds devote such craft, effort, and ingenuity to achieve this life-defining moment.
So if the artificial intelligence is being programmed with evolution, the sort of red and tooth and claw, the survival of the fittest, where does the aesthetics of the bowerbird fit in? The male bowerbird could be a weakling, a complete twerp as far as the female is concerned, but what he creates is aesthetically pleasing. How do you program that into artificial intelligence? So to finish up our day's journey, I'd like to put this video up. It's a fixed camera on a container freighter and follows it for 30 days. And it's a high speed, or a slow-mo, I should say, a slow-mo camera. I'll show you a segment of this and enjoy. Isn't that really beautiful? It really helps you understand what a bias we have. We're speed chauvinists. We have a biased sense of time, and sped up cameras and slowed down cameras bring things into a proportion that makes us sort of, at least makes me feel a little more humble. That's all we have for time for today. I want to let you know that with your email that I'll be sending out, there'll be an invite to Zoom at 12 o'clock on Tuesday. That's in Science Tech Nature San Miguel time. And I hope you can join us then. I look forward to doing this for next week. And as I've said before in the other presentations, I so look forward to seeing you in the flesh again. Be safe, everybody. Goodbye.